In this video, we want to talk about all different kinds of lines and the angles that are created when lines intersect each other. So we're going to start with some basic lines. First of all, we want to recognize the difference between a line segment and a line. So a line segment has defined endpoints, and you usually see dots at the end of the line. So this means that the line stops at this point and stops at this point, and it just spans this length here. Versus a line with arrows on the end means that this is a line that goes on forever in both directions, and we're just showing this particular portion of it. One thing that we can do with lines is find the lengths of particular line segments. So for example, you might be given a problem like this one. It says, if the line segment, that's what this means, the line segment AB is equal to the line segment BC, and if the line segment BC has a length of 12, then find the length of the line segment AC. So we're being told that AB, which is the distance from point A to point B, that this has an equal length to BC, which is the distance from B to C. So we can see just by looking at the figure that the point B cuts the line segment AC in half perfectly. And we've been told that BC has a length of 12, so this is a length of 12. Well, if these two line segments AB and BC are equal to each other, then we can conclude that AB must also have a length of 12. So then we're asked to find the length of AC, which is the entire line segment, A all the way to C at the end. We can say that the length AC is equal to 12 plus 12, or 24. We also want to be able to do problems with intersecting lines. So for example, we might have a problem like this one, where we've been given two lines that intersect each other, and we've been told that those intersecting lines create angles between them. So we have angle 1, angle 2, angle 3, and angle 4. And we've been told that angle 1 has a measure of 140 degrees. The interesting thing about intersecting lines is that they create two pairs of equal angles. So opposite angles will always be equal to each other. In other words, in this figure, angles 1 and 3 are going to have an equal measure, and angles 2 and 4 are going to have an equal measure. So since we've been told that angle 1 has a measure of 140 degrees, we know also that angle 3 has to have a measure of 140 degrees because these two angle measures will always be equal. We also know that a full rotation all the way around in a circle is 360 degrees, which means that we can also find angles 2 and 4. So we could say 360 degrees, which is always the total, minus 140 degrees for angle 1 and 140 degrees for angle 3. If we sum those two together, 140 plus 140 is 280. So if we subtract 280 from the full 360, we get 80 degrees, which means angles 2 and 4 together have to sum to 80 degrees. Since we know that they are equal to one another, we know that angle 2 has to be exactly half of 80 degrees, and angle 4 has to be exactly half of 80 degrees. So we know that angle 2 is 80 over 2, 40 degrees, and that angle 4 is 80 over 2, 40 degrees. So with all of these angle measures, 1, 2, 3, and 4, we could find any value that the problem asks for. In this case, it asks for the sum of angles 2 and 4. Well, we know that angle 2 is 40 degrees, angle 4 is 40 degrees, so angle 2 plus angle 4 is this 80-degree value that we already found. We could have also done this problem by taking advantage of the fact that straight angles always sum to 180 degrees. So for instance, if we look at angles 1 and 4, angles 1 and 4 form this angle here. If we just sketch a line and then this angle measure right here, we can see that they form a straight angle. In other words, we have this straight line, and angles 1 and 4 are the entire half of the circle on this lower side of the line. Well, we know a full circle is 360 degrees, so a half circle always has to be 180 degrees. So we know that angle 1 and angle 4 have to add to 180 degrees, and since we know this is 140, we know that angle 4 has to be 40 degrees. We also know angles 1 and 2 have to sum to 180, angles 2 and 3 have to sum to 180, and angles 3 and 4 have to sum to 180, because each of those pairs forms a straight angle. So if a full circle is 360 degrees, and a half circle, a straight angle, is 180 degrees, then a quarter circle is 90 degrees, and we call those 90-degree angles right angles. So that might look like this. If we have two lines that intersect each other, they're going to form a 90-degree angle in between them. So this angle here will be a 90-degree angle. We always indicate that perfect 90-degree angle with this little square here in the corner, or by saying that two lines are perpendicular to one another. So we have the line OY vertically and the line OX horizontally. We can say that those are perpendicular to one another with this little perpendicular symbol here. That's what that means. That means perpendicular. Never assume that an angle is 90 degrees. Even if it looks like it might be 90 degrees or might be close to 90 degrees, you never want to assume that that's its measure unless you're told that two lines are perpendicular, or you're given this square here to tell you that the lines are perpendicular, or that you're being told that you're finding, for example, an interior angle in one corner of a square. And by the definition of a square, you know that that interior angle is 90 degrees. But assuming we know that this is a right angle, then we can do problems based off the fact that we know that this is 90 degrees. For instance, if we're given this problem where we have this angle bisector here, this line, and it forms angle 1 and angle 2, and we know angle 1 is 40 degrees, if we're asked to find angle 2, well, we already know that the entire angle is 90 degrees. So to find angle 2, we just take 90 degrees minus 40 degrees, and we get 50 degrees. So the measure of angle 2 must be 50 degrees.